So when we start graphing, a few things we need to start thinking about. And a big part is going to be setting up our x and y axes. The y-axis typically isn't too bad. We'll just kind of use our amplitude and midline to get an idea of what we need to see along the y-axis. The trickier part can be our x-axis, and with that we'll really rely on the period for setting that up. Again, with sine and cosine, so those are going to be our kind of basic functions that we'll be working with. So with sine, it starts at the origin and goes up. So one full period looks like this. And again, I'm going to keep bringing up those kind of 5 special points. So we have a beginning and end. Halfway in between, we cross there. And then halfway between those, we have our peak and the value, or minimum and maximum. And then with cosine, same idea. It's just we start at the peak. So we start at the maximum and then go down and then back up to the maximum. And with that, halfway in between those values is the minimum. Then halfway between there, we're crossing that midline. So I'll be bringing up those ideas and kind of knowing our basic function as we go into this. So this first one is cosine. So I'm just going to make a sketch over here of cosine looks like this. So I have an idea of the general shape, and then I can apply all of the other movements to it. We always want to see the origin in our graph. So what I'm going to do is I'm going to go ahead and draw the y-axis kind of over here, because typically we don't need to see too much of the negative side of x. Mostly everything's happening on the positive side, and that's what's kind of nice about these periodic functions, is that the shape repeats itself. So whatever we see on the positive side is also happening on the negative side. So we don't need to worry about missing out on anything really. Then determining the x-axis, and I mean basically where I want to put the x-axis. Do I want to put it here? Do I want it way up here? Do I want it down here? And with that, I'm going to look at the amplitude and midline. So my midline is at -3, so it's kind of low, and then I have an amplitude of 2. So using those two values together, I have an idea of the possible outputs of my graph. I could even describe the range of the graph at this point. That, let's see, we'll have 2 values, and it'll basically come down to the midline plus or minus the amplitude. So the midline, let's see, -3 minus 2 would be -5, and -3 plus 2 would be a -1. So that gives me an idea of the possible outputs I'm seeing. So I'm seeing values from -5 to -1. So with that, I'm going to put my x-axis kind of high up, because it's all kind of happening down here. I'm going to go ahead and put the x-axis here. And with that, I'm going to go ahead and label the y-axis. And I'm going to use units of 1. So we'll have -1, -2, -3, -4, -5. That gives me a good visual for what's happening there. With that, I can even kind of start to create the barrier for the graph. I mean, we have our range. So the midline of the graph is at -3. So I'm just going to go ahead and draw kind of a dotted line there. So that's going to be the middle of our graph. And I'm going to go to above, and that'll kind of create a barrier for the maximum of the graph, and then down to for the minimum of the graph. So with that, I use the amplitude and midline to kind of figure out what outputs I could have, and then the amplitude and midline can kind of create these 3 lines for the barrier of your graph. Now our period is 2 pi. And our question would be, like, do I want 2 pi to be here? Do I want 2 pi to be here? And what you want to think about is, basically on our graph, going from that maximum to the next maximum is a distance of 2 pi. And kind of keeping in mind these special values, it's kind of like there's 4 pieces to this. There's 1, 2, 3, 4. So with that, when I set 2 pi and basically its location, I use an increment of 4 because that helps me place those special coordinates. So with that, I could put 2 pi right here, I'm going to stretch it further, mostly because then that just kind of happens quickly, and I kind of want to stretch it out a bit. So I'm going to go a distance of 8. So keeping in mind those kind of increments of 4, you absolutely don't have to use increments of 4, but it's really helpful. So I'm going to go, that's 2 pi, which means halfway in between there is pi. So this is going to be pi over 2. So 3 pi over 2. And we could keep labeling, that's really good enough. And then our graph will continue on, and it will continue over there. So with that, I use the period to help place values in the graph, and mostly I set it so that it's an increment of 4 away, either using 4 or 8 or 12. That usually tends to stretch it too far. But all right, now we can start graphing. So there's no phase shift here, so that kind of helps a lot. We don't need to worry too much about that. So what I'm going to do is now place my 5 special points. So in terms of cosine, it's going to be that we start at a maximum, halfway in between the end of the period and the beginning is our minimum, and then we cross the midline at those 2 points. So how I'm going to graph this is, I know on the y-axis, since there's no phase shift, cosine is starting here. And my period is 2 pi, so I'm going to end up back at that point when we reach 2 pi. Now halfway in between there, we're reaching our minimum value. So at pi, we're reaching that lowest point. Halfway between those values, we're crossing the midline. So with that, I get 1 period of the graph, nicely drawn out as best I can, like that. And then what you can do is keep graphing points kind of using these increments of something special happens 2 away and just kind of following the pattern of the graph. So if we're at the maximum, then we're going to cross the midline, hit the minimum, and then it goes off the page. Over on the negative side, let's see maximum, and then midline, and then it goes off the page. So really I could continue more of that information beyond the 1 period, like that. And we do all of this work, and then a brilliant idea is to check your answer. And by that, we're going to go to Desmos. So I'm going to get rid of that graph, and I'm just going to plug in 2 cosine, cosine of x minus 3. Now I could just check some key points. So there we have our 0, -1, perfect. At 2 pi, we're at that same value, halfway between the minimum at -5. The midline can be a little tricky to see. If you wanted to visualize the midline, you could actually graph it of y equals -3 and check those kind of intersections with it. That's great too. So when you get to the end of these, you can always check your answer by plugging into the calculator. So in terms of what I'm looking for with you creating these graphs, I want to see at least 1 period of the graph. That's really important because that's where really the information is, because then beyond that, it's just repeating. And then if you could clearly mark these 5 special points, that's perfect. In terms of graphing every single coordinate perfectly in here, that's not required. It can help if you need to find those values. You can just plug them in, like plugging in pi over 4 and seeing what comes out. You can absolutely do that, but it's not required. This is basically what I'm looking for. Alright, let's do this a few more times. So, we have that negative sine of 3x. Now, the special piece with this is that we have that negative out front. So we're going to be reflecting over the x-axis. Alright. So if I think about my general shape of sine, so sine goes like this over 1 period. And if it helps at this point, you could reflect it if we wanted to. We could draw it like that for negative sine of x, just to kind of get that visual going in our head. Either way, now that I've drawn that, let's go ahead and do that. So in terms of the special points, we're going to have the beginning and end. Halfway in between, we'll be crossing that midline again. And then we'll actually, since it's reflected, start with the minimum and then go to the maximum. Alright, amplitude is 1, midline is 0, so we're not moving around too much. What we're really changing is the period of the graph. So with that, setting up my x and y axes, I can have it kind of centered, and it doesn't matter too much where we put it as long as we can see at least one period. I'm going to do this. Okay, that worked out nicely. I'm going to label my axes so we have x and y. Now I want to see to 1 and negative 1 on the y-axis. I can kind of stretch that out a bit so it's nice visually. So I'm going to have 4 of those boxes is equal to 1 on the y-axis. And now, setting our period. So like I was saying is, I want that period of 2 pi over 3 to be an increment of 4. That can either come through with just a distance of 4, or if you want to stretch it out further, you can make that 8. Let's go ahead and make it 4. It doesn't particularly matter. So what should happen is between 0 and this number, and this because there's no phase shift, between 0 and that number, I should see this full cycle coming through, that full period. If you want to label some more of the pieces there, so half of 2 pi over 3 is just pi over 3. Which means we're seeing pi over 6 here. 2 pi over 6, 3 pi over 6. So we're using these increments of pi over 6. Really, I just want to see that, you know, what kind of that distance of 1 is, or even like up above here, that distance of 2 is pi over 2. We could have kept labeling like pi over 4. Just some definition of what these increments are representing. Alright, so midline is going through the x-axis. Maximum value should be hitting positive 1. Minimum value should be hitting negative 1, based on our amplitude midline. No phase shift, so now we just need to create a graph within that one period there. So what I'm going to do is mimic these points I did up here with that reflected sine of x. So we have 0, 0, and we should be seeing that kind of that point again after one period, which is 2 pi over 3. Halfway between those two values, we should be crossing that midline again. Halfway between those values, we should be hitting the midline, or sorry, the minimum, and then maximum. So with that, you can see one period of our graph from 0 to 2 pi over 3, amplitude of 1, midline of 0. And then from there, I'm just going to continue these points on so that we can see our graph stretched out. But once you set that single period, that should set you up for the rest of your graph. That continues on, and then just connecting these dots. Ooh, I might have gone too fast there, but it's good. Good enough. That one period I have there is very clear. Alright, so as you could tell, if I had done 2 pi over 3 at a distance of 8 units, that would have stretched it out. You would have less, but it's the same thing. Okay, with this one, we found this had an amplitude of 4, period of 1, no phase shift, midline of 4. Alright, so with this, let's go ahead and put the y-axis somewhere over here. Now, in terms of the y values that I need to see, again, I could think about the range of the graph since I do have a special midline and amplitude here. So the midline minus the amplitude, so 4 minus 4, so that's going to be hitting 0. And it's going to go all the way up to the midline plus the amplitude, so 4 plus 4, 8. So I need to see a lot of y values here, at least 8 of them. So maybe I'll put the y-axis, or sorry, the x-axis here. 1, 2, 3, 4, 6, 7, 8. Perfect. I'm going to use a distance of 1 there, 2, 3, 5, 6, 7, 8. Alright, so that sets up my y-axis. And if you wanted to, at this point, we could draw how that midline and amplitude are working together. So at 4, we're going to have the midline. For above, we'll have our maximum values. And for below will be our minimum values. And sorry, I should have drawn this at the beginning. We're working with sine here. And it's not reflected, so we go up to the maximum, minimum, and we have these kind of 5 special parts. Alright, period is equal to 1. So what we're going to do is label 1 on the x-axis in some sort of increment of 4. I'm going to go ahead with a distance of 4. I could have done 8, that would stretch it out further. I'm going to call that 1. So there's a half. Here's 1.5. Here's 2. Just for some extra values there. Okay. So, with that, I have my midline, my minimum and maximum values. My starting point, since there's no phase shift, my starting point should be on the midline. What I'm going to do is graph my point right there. And then we should be returning to the midline, at least kind of starting over the period at a value of 1. You're going to see that value come through there again. Halfway in between those 2 points, to match the shape of sine, we should be crossing that midline. Halfway between 0 and that value at 1/2, we should be reaching our maximum, and then our minimum. So, we're up to our maximum, minimum, and returning. And there's 1 period of our graph. And then I would just continue that routine to fill up the rest of the graph. There we go. And then same thing over here. Continue that routine. Over there. All right. Okay, our last one, and it's a big one. So, we're going to have a phase shift here. Let's have a new period and amplitude. Our midline's staying nicely at y equals 0. So with that, I'm probably going to have my y-axis pretty much in the middle here. 2, 4, 5, 6. Alright. And then the y-axis, I just kind of put over here. You could put the y-axis right in the middle. That's fine too. I just find that working with the period and the phase shift and labeling the x-axis, I find I'm doing most of my work over here, because on the positive side it's just a bit easier. So it's my personal preference to just kind of scoot the y-axis over so I can focus on what's going on over there. Alright, so all these pieces working together. Now the midline is y equals 0. That's going to be the middle of our graph. And then amplitude is 1/6. So with this we can kind of get creative with labeling our y-axis. Let's go ahead and say 6 of those squares is equal to 1. Which means this would be a half. Which means this would be a 6, 2 6, 3 6, 4 6, 5 6. You don't need to label all of those, but just so that we can see, if I choose that distance to be 6, then I get my nice 1/6 there without having to do too much estimation. So, with that, my maximum values are just going to go up by 1 there, and minimum values down. That I have the start of my graph, or at least where it's kind of restricted. Now, with the negative, we're going to have a reflection over the x-axis. So with that, we're working with cosine, which typically does this over 1 period. What I'm going to do is just reflect that, so that where we usually start at the minimum, I'm going to start at the maximum, cross the midline, go to the maximum, cross the midline, end up at the minimum. So for negative cosine of x, we're going to have this general shape. I'm going to follow that trend and have those kind of special points coming through. All right. So, period of pi over 2 and a phase shift by pi over 16. So, I'm going to set the period to pi over 2. And again, you can use these increments at 4, or you could set it at 8 away. We have been kind of setting it at 4, and that's been fine. We see a lot of information by doing that. What I can notice then is what we'd have pi over 2, pi over 4. So we'd see pi over 8, and pi over 16 is halfway between there, which is completely fine. But if I just stretch out that pi over 2, I can see it a bit more clearly. So what I mean by that is I'm going to put pi over 2 an increment of 8 away. So halfway between there is pi over 4, and halfway between there is pi over 8. So that makes that pi over 16. So I can clearly see that spot that I need to shift over to. So with that, we have our increments of pi over 16. You can just, you don't need to label all of those points. I'm just going to leave it like that because I can see my kind of key values that I'm working with there. Alright, so with cos negative cosine, we would be starting at the minimum because of that reflection. So without a phase shift, I would be starting down here, but what we have is a phase shift to the right by pi over 16. So where I would be down here, I'm going to move that to the right by a unit of pi over 16, and that's where it's really nice to see that block there, because then that means I just move right there. Now the period is pi over 2, and notice that the distance of pi over 2 is this distance here, or you could think of it as 8 squares. Since we moved over by one of those squares, that means in terms of returning to that minimum point, it wouldn't be at pi over 2, it's shifted over so that it's 1 square to the right of pi over 2. Alright, halfway between those values, we should be reaching our maximum. So that should be a distance of 4 squares. So that would be up there. Halfway in between those, we should be hitting the midline. And there. So it's basically every 2 squares something special is happening. So I go over here, we could cross the midline, over here, midline, maximum, and then down below. So this is pretty nice and stretched out, but we can really see everything. I just need to be careful connecting the dots. And that would be our graph. Okay, so what I've described here is my routine, my thinking with graphing these transformations. If you've done these before and you have your own way of going about it, that's completely fine. In terms of my requirements for graphing, what I want to see is one period of the graph, so at least one period, then going beyond that's fantastic. You need to label your x and y axes, so setting the scale, and what I've tried to include were kind of tips for setting your x and y axes, so it kind of helps to make the graph. And then with that, just labeling some clear points, and those easiest points to graph are going to be those minimum, maximum, and midline values, since they kind of occur nicely in terms of symmetry in these kind of quarters of a single period.